Hi there, here is Unit 5, Lesson 6. And if you watch the video for Unit 5, Lesson 5, you're going to recognize three things that we're talking about, okay? In Lesson 5, we talked about determining slope, or rise over run, x-intercept, and y-intercept, okay? But when we did Lesson 5, last lesson, I gave you a picture of the line or the graph already, and we just used the picture given to determine the slope, x-intercept and y-intercept, and it was quite easy. The difference with these questions today is that I don't give you the graph. You actually have to draw it, okay? And in order to draw it, we have to do some calculations to find the x-intercept and y-intercept using the equations. This is an equation of a line. We're able to actually draw this line out and see what it looks like. Okay, in order to do that, we're going to do the method of finding the x and y intercepts. And you can see in the instructions here, it says for each equation below, determine the x-intercept and the y-intercept. And in brackets, I said to find the x-intercept, substitute y with 0. So we talked about that in last lesson. When we find the x-intercept, we know at that point that y is 0. When we find the y-intercept, we know at that point that x is 0. What we're going to do is we're going to find those 2 points, we're going to draw them, and then we can determine the slope from there. So I'm just going to zoom in on this section here. I'm going to show you the work of finding the x-intercept. So this is the first thing I'm doing. Number 1 here, determine the x-intercept, substitute y with 0. So I'm going to kind of just draw a little title here. Actually, I'm going to create a table. I'll find the x-intercept on the left side, and I'll find the y-intercept on the right-hand side. A little t-chart for you. Whoops, there you go. So to find the x-intercept, like I said, we have to replace y with 0. For the y-intercept, we have to replace x with 0. So we take the equation I give you. I'll always give you the equation. And for x-intercept, where we see a y, so right there, we replace it with 0. So we rewrite the equation, negative 2x plus 2, but instead of y, we replace y with 0. Recopy the rest of the equation. Now, we should know that anything times 0 is just 0. So really, this whole thing here, this whole term, all goes to 0. It's like it doesn't exist anymore. So all we have is negative 2x on the left-hand side and only 6 on the right-hand side. Now, we have to isolate x. That's what we're trying to find. We're trying to figure out the x value. X is not alone. It is multiplied to that negative 2. So to get rid of a multiplication of negative 2, we have to divide by negative 2 so that they cancel each other out. But what we do to one side, we have to always be fair and also do to the other side. So when I simplify, on the left, I have x completely isolated. And then on the right-hand side, I simplify that. 6 divided by 2 is 3. And it remains negative because a positive divided by a negative is still a negative. So that means my x-intercept is negative 3. I'll draw that in a second. We'll do the y-intercept next. So for the y-intercept, where it crosses the y-axis, at that point, I know x is 0. So I do the exact same thing here, but I replace x with 0. So it looks like this. Negative 2 times 0 instead of x plus 2y equals 6. I know this whole thing is just going to end up being 0 because negative 2 times 0 is 0. So all that's left is this chunk. So all I have left is 2y equals 6. I need to isolate y, same thing I did over here. I'm going to divide off by what I want to get rid of, which is just 2. And I have to do it to both sides. Those cancel. Y is isolated. And on the right-hand side, it's just 6 divided by 2, which is 3. Okay, so I'm going to go over to my graph now. So I'm going to zoom back out and we're going to draw this to be able to determine our slope. So it says my x-intercept is negative 3. So on the x-axis, I find negative 3 and I put a point there. Then my y-intercept is positive 3. So I go to my y-axis and I find positive 3. Okay, And then you would join those two lines with a ruler. I did not bring my ruler with me to this, so I'm just gonna try my best to draw a straight line. And there is a picture of your graph. Now we learned in the last video for lesson 5, to determine slope, we go rise over run. So that's the third thing I'm doing here. Graph these points, which I did, and determine the slope. So rise over run means I take my 2 perfect points I just drew, and I rise 1, 2, 3. So I went up 3, to the right 1, 2, 3. I said last day that if you ever travel up, it's positive, down would be negative, and to the right is also positive. To the left would be negative. Okay, so it's positive 3 over positive 3. So I'll do my slope over here. So my slope is my rise, which is positive 3, over my run, which is also positive 3. And if I simplify those, it just equals positive 1. So my slope is just 1. There you go. Okay, next one. I'm going to do the x and y intercept. Okay, so same thing. I'm going to do kind of this T-chart here. Find my x-intercept on the left. Find my y-intercept on the right. To find my x-intercept, I know y is 0. To find my y-intercept, I know x is 0. And all I do is I take my new equation and I get to work. So x-intercept, I plug y in with 0. So 4x minus 3y, but y became 0, equals 12. I know this whole term's actually just going to go away because it equals 0. So the negative goes away as well. All I have is 4x all by itself on the left and 12 on the right. The final step's going to be always the same. We have to divide off by what's multiplied to the x, which is 4 on both sides. Those cancel, x is isolated, and 12 divided by 4 is 3. Over here, I do the same thing, but I replace x in the equation with 0. I know that whole term is going to completely go away. Be careful though, you still have a negative 3y. So negative 3y equals 12. You divide off by exactly what you want to get rid of, which is negative 3. Negative 3 over negative 3 cancels. You have y all by itself. 12 divided by negative 3 is negative 4. So now you take those 2 points. My x-intercept was at x equals 3. So there you go. My y-intercept was at y equals negative 4. So I'm down here. You would join those with a line, preferably with a ruler. And now you figure out your slope, which is how much do I rise, how much do I run? I rise 1, 2, 3, 4. So rising means positive, going up means positive 4. And I go to the right, 1, 2, 3. Going to the right is also positive. So my slope is positive 3 over positive 4. You don't need to write the 2 positives. It would just be 4 over 3. Okay. 2 more on this side. I included these because something is a little bit different when we're finding the x and y intercepts. We have one extra step of work to do. So again, I'm going to start with my T-chart here. I'm going to find my x-intercept in the left column, my y-intercept in the right column. I know when I'm finding my x-intercept, y goes to 0, and for my y-intercept, x goes to 0. Okay, so do exactly the same thing. 5x plus 4y, but in this case, y is 0, minus 20 equals 0. So I rounded a room there. I know this whole term goes away because 4 times 0 is 0. So all I have now, I have 5x, but my left-hand side still has the negative 20 on it. And then my right-hand side was equal 0. Now here's the thing, I have to isolate x. And in the other examples, if we go back, our constant term was already on the right-hand side. See, the 12 was already on the right, the 6 was already on the right. We're going to do that here too. We're going to put this negative 20 onto the right-hand side. But be careful, because when you take something and move it to the other side, the symbol is going to change. Or another way of thinking about it, if I want to get rid of negative 20 on this side, I have to add 20. And what I do to one side, I have to do to the other side. So in either scenario, however you think about it, we're going to end up with nothing or no 20 on this side anymore and a positive 20 on the right-hand side, because this negative 20 is just like hopping the fence to the other side. Its symbol changes. So we have 5x equaling now positive 20 on the right. I divide off the 5, x equals 4. Okay, same thing here, but now this term is going to become 0 because I'm replacing x with 0. 5 times 0 plus 4y minus 20 equals 0. That's gone, it equals 0. So I'm going to do 2 steps in one here. I have 4y on the left-hand side. I know I'm eventually going to have to switch that over to the other side, so I'll do that right here. It becomes positive 20. Divide by 4 to get y isolated, and y equals 5. So now let's go draw these. So my x-intercept is positive 4. My y-intercept is positive 5. You would join those, and there's the graph. Now to figure out your slope, we do rise over run. So if you start here and you want to end up here, you'd actually have to go down. So that means my rise is actually going to be, I'm going to be descending. I'm going to be going down. 1, 2, 3, 4, 5. So remember, down means negative. And 1, 2, 3, 4 to the right. Going to the right still means positive. So my slope is actually negative 5 over positive 4, which is really just negative 5 over 4. You don't need to write that positive, but a negative and a positive remains negative. Okay, and a negative slope makes sense because it's like a downhill slope. We'd be running down this hill. Whenever we're running down a hill, it's going to be a negative. Okay, last but not least, this one. I'm actually not going to talk through this one. I challenge you right now to actually pause the video and try doing this one on your own and seeing if you end up with the same answer as me. So I'm just going to get to work here. Okay, so pause me if you're not done yet. This one is actually a little bit tricky, finding the x-intercept, replacing y with 0. So you'll see here I took my equation, negative x plus y. So negative x plus, well, y is 0, minus 1 equals 0. Now, y is just y. There's nothing attached to it. So it just looks like plus 0. So I know that that actually doesn't need to be there. So I technically just have negative x minus 1 on the left-hand side equaling 0. Just like in the other question, I'm going to want to send this negative 1 to the other side. When I do that, it becomes positive. So that's how I got from here to here. I just took my negative 1 and flopped it over. It became positive 1. Now here's the thing. I don't want negative x. I want just x. I want it to look like this. I have to get rid of that negative. So because there's no number in front of the x, we know that there's actually like a 1 there. So we can divide off by negative 1 because 2 negatives cancel out. So I have a positive x. But if I do it to both sides, this one would actually change symbols because a positive 1 divided by a negative 1 equals negative 1. So again, I divided by a negative 1 on this side because I wanted these 2 negatives to cancel out. So it was positive. What I do to one side, I have to do to the other side. Here, a positive divided by a negative is actually a negative now. Over here, this one's easier. I replace x with 0. So it's like I have negative 0 or negative, like negative x became negative 0, which doesn't really matter. I don't have to write that. So all I really have is y minus 1 equals 0. Again, I'm going to move that 1 to the other side. It becomes positive. Y is perfectly isolated. I don't have anything else to do. I came over here, I drew my x-intercept as negative 1, my y-intercept as positive 1. I connected them with a line. All I have to do here for my rise is up 1, and then my run is over 1. up is positive, to the right is positive, 1 over 1 is just 1. So I've attached an optional assignment as well. Again, email me if you have any questions.